Here we are on the final review for Chapter 7, which is algebraic expressions. We will also do Chapter 8, which is inequalities and equations. So the big idea for Chapter 7 is algebraic expressions can be used to describe situations and solve problems. And we know that God is without error. He is truth. He created the world, that there are correct and incorrect answers to math problems with, of course, many ways to reach the correct answer. So we can apply the biblical truth to this chapter. We remember that algebra comes from the Arabic word algebr, which means the reunion of broken parts. So just like we reunite broken parts into a whole in algebra, God also reunites us into his whole as people who follow him. We can also think of parts and whole in math, remembering that that is broken apart can be made whole again, reminding us that God makes us whole when we are broken, just like algebra is stating. So, just a basic review of Chapter 7, remembering that expressions would not have an equal sign versus equations would have an equal sign, and then inequalities would have a greater than or less than symbol moving into Chapter 8. So if you look at lesson 7.1, which is on starting on page 221, but we're going to go to the guided practice on page 223. So basically it's telling you that you can use variables to represent unknown numbers and write addition and subtraction expressions. So if I have 5 plus 18 equals 13 here, I have that equation. Here, I can write down my equation. I could say v or x or z. It really doesn't matter what I would write down. Plus 9 equals 12. So to find this, I would do 12 minus 9 equals, and you guys know it's 3, right? But I'm going to use a variable to represent that. So I might write the number of x plus 9. Okay, so this would be my expression. And then it makes it an equation when I add on the equals 12. And then I can actually solve it. But for now, I just want the expression. So the expression is x plus 9. And it becomes algebraic when I have a letter that stands for something I don't know. Okay? We have a word that's called term. This is a vocabulary word, and as well as algebraic expression and variable. So this is also vocabulary, this, and the word term. So you need to know what those are. But the terms in this algebraic expression would be the x and the 9. Okay. We also know that x is one of the variables, so it's any letter that represents an unknown number again. Okay. So if we come here, we have 24 minus 10 equals 14. This is an equation. So we have unknown number minus 6 in terms of y. So I would write down y, and then it would be minus 6. So the algebraic expression is y minus 6. The terms are y and 6. The variable is y. Okay, and then I can write division and multiplication expressions as well. So if I had Z crackers in 4 boxes, I could say Z in 4. So it would be multiplied. And then remember the coefficient, which is the number, always comes first in an algebraic expression. So it's 4Z. So even though Z times 4 is the same as 4 times Z, it's going to equal the same product. This is the correct answer. So again, the number is called a coefficient. And then this is still a variable. Okay, moving on to 7.2. That starts on page 226. So then you can evaluate your algebraic expressions for this variable. So you just take the 5 for x and you replace it. So you have the expression x minus 3 and you replace the x with 5. 5 minus 3 is equal to 2. And you do the same. And then algebraic expressions can also be simplified. So if you have y plus y, this is the same as 1y plus 1y. And we know 1 plus 1 is 2. So that's 2y. Okay. Remember, this is different than y times y. Y plus y is 2y, but y times y is y squared. Think of area. Okay. These are not the same. Okay. Then I could also evaluate that. And then you remember that like terms can be added and subtracted. So if I have 3x plus x, that's the same as 3x plus 1x, which would be 4x, because 3x is x plus x plus x, plus the other x would be 4x. And then again, you could evaluate it. 3x plus x, checking your work, x equaling 2. That would be 3 times 2, which is 6, plus 2 more, which is 8, and checking to see if that's the same as 4x, which you found when you simplified. And 4 times 2 is 8. So checking your work, they both equal the same thing. Okay. You can also subtract like terms. So 2v minus v, that's the same as 2v minus 1v, which is v. So you check 2v minus v, the original expression, and compare it to simplified expression, which is v. Substitute in a number. So 2 times 3 for the v minus 3 would be 6 minus 3, which is 3, and then v is just 3. Okay, and then order of operations, you can either use the GEMS or the PEMDAS. So remembering that we have parentheses that you have to solve first, then exponents, and then multiplication and division left to right. So if the division came first, you would have to solve that first, and then the multiplication, addition, and subtraction left to right. So if you need help on more of those problems, you can do those. And then just remembering to collect like terms. So on this one, if you have r plus 8 plus r plus 8, the r's get combined. So r plus r is 2r. And then a positive 8 and a positive 8 is a positive 16. So I have 2r plus 16 is your final answer. Okay, and then we moved into lesson 7.4 where you're expanding algebraic expressions using the distributive property. So distribute just means to rearrange it in a different way. So if I have 4 times 4y minus 1, so foiling method, if you like the pictorial method, you can go back and look up how to do that. So foiling, you would do 4 times 4y. So 4 times 4y is 16y. Minus, because we have a minus sign here, 4 times that minus 1, so that would be negative 4, so I have the negative here already, so minus 4. And I don't simplify this because if I simplify it, I'm going to end up with the 4 times 4y minus 1. So simplifying this would mean factoring it, which we're going to do next. Okay, some of you like the box method. So you do it this way, kind of like factoring, like the greatest common factor. So this would be 4 times 4y is 16y. And then 4 times the negative 1 is negative 4. And you get your answer there. So very similar to foiling, just with a little bit different visual. So however your brain works is fine. And then you should check your work by filling in both the y, the variable value for both, and offset them to make sure they're equal. So I would do 4 times times 2, the 2 for the y here, minus 1 equals 16 times 2 minus 4, and then follow order of operations. So this would be 8 minus 1, and then 32 minus 4, doing each step as you go. So 28 equals 28. Okay, and then to find whether these are equivalent or not, you just solve for that variable. And then factoring algebraic expressions is just the opposite of expanding an algebraic expression. So you have 2y plus 10. You just find a common factor, preferably the greatest common factor. So this is where you're using the distributive property to take the greatest common factor and then put the sum of two other numbers inside the parentheses. Okay, so a lot of you know this method where you have the 2y plus the 10, and then you factor out the greatest common factor or a prime number. You can use prime factorization. On this one, the prime factor that comes out of 2 and 10 happens to be the greatest common factor. So 2, and then I would get 1y plus 5. Okay, so then when I put that outside of my parentheses, I have 2 times 1y plus 5. Because 2y divided by 2 is 1y, and 10 divided by 2 is 5. Okay, so just like before, for your final review, you can go into the chapter review, preview, and review some of the problems that you might have put a check S or E on that you need to further study. If you put checks on all of them, or if you only have 1 or 2 problems that you need to review the concepts, I would for sure go into some of the word problems from this chapter as well. So next up will be chapter 8.